Hello and welcome to Excellent Link Academy. For today, we're discussing a very important topic in physics called conservation of linear momentum. Let's discuss the concept behind conservation of linear momentum. The principle of conservation of linear momentum states that it has a law, right? So I'll be stating the law as we proceed. So let's discuss conservation of linear momentum. Note that the principle of conservation of linear momentum states that in a system of colliding body or object, the momentum is always conserved, provided that there is not external force acting on the system. So I'm saying that the law of conservation of linear momentum states that in a system of colliding body or object, that the momentum of the body is always conserved, provided that there is not an external force acting on the system. No, it is not that it can also be stated as if two or more bodies collide in a closed system, that the total momentum before collision is equal to the total momentum after collision. All right, from what we have stated now, you have been hearing the word collision, collision, collision. What is collision by definition? Collision is a forceful, sudden coming together of two bodies in direct contact. So if two bodies, let's say body A and body B, come together, collide, when they come together by a forceful or sudden coming together of two bodies A and B, that's said to be what the collision. So when two bodies hit against each other, it's said to be what the collision. All right, let's derive the mathematical expression for conservation of linear momentum. All right, to explain the concept of collision, let's say I have a body A. Let's say I have an object A. Let's call it A. This object A moves with an initial velocity of A. It moves in this sense, this way, like this. And I have an object B. Let me call this one moves with initial velocity of B. Initial velocity of B is moving in this sense. This is what during collision. Sorry. So this one is called before collision. This one here is called before collision. I'm having an object here and an object here. So this object here are coming in opposite direction. B is going like this, while object A is moving like this. So they are both what? Trying to what? To collide. So this is what? Before collision. So at this point here, when object A and object B hit each other, I'll have something of this nature. Let me call this A. Let me call this B. Object B. Object A, object B. So this object object A moves object A moves with the force. Let me call it FA. Right? And object B also hits object object B, object A with a particular force. Let me call it FB. Right? Let me call it FB. So this is before collision. The objects are separated such that they are coming in opposite direction. Now, this is what we refer to as during collision. This is during collision. The two of them have hit each other. So I'm having something of this nature here. So this is what during collision. During collision. So these two objects here have hit each other. Now look up, please. Look up, please. Observe that A is smaller, B is bigger. If these two objects hit each other, it's likely for the two objects to move in this direction, or for the two objects to move what in this direction. Now you don't determine the direction by the object with bigger mass. Looking at this now, neutrally looking at this as a layman, looking at this now, if these two bodies hit each other, if B go this way, A is going to this way. Why? Because B is bigger in mass, right? Is bigger. So it means that if these two objects collide together, it's possible that this B will what take what's it called? If this B moves this way, it means A is going to what move this way. Now that idea is a wrong idea. Now listen, I'm having B, object B is big, I agreed. Object A is small. But if these two objects hit each other, to determine direction, the direction is determined by which of these two has a bigger momentum. So let's say that A has a bigger momentum and B has smaller momentum. It means that the two of them will move in this direction. So far A has a bigger momentum. So we are not looking at the B as at the mass or the bigger the object is. We're looking at the one that has a bigger momentum. So if let's say if A has bigger momentum and these two hit each other, it means that they're going in this direction. But in another case, if let's say B has a bigger momentum, it means that if A and B hit each other, it moves in this direction. So let's agree that they are moving in this direction. It means that let's say I have object A moving in this direction after collision. So let me say it moves with the final velocity of A, right? Final velocity of A, and object B also moves with the final velocity of VB. Let me call it VB. So let's say after the two objects collide together, they are both moving in this direction. This, I just assume this. If let's say if A has bigger momentum, it means that they are going in this direction. But let's assume that they are both going in this direction. I'll have something of this nature, right? So this is after collision. After collision. So this is before collision, during collision, and after collision. So I have this diagram here. All right, with this diagram here, we'll try to derive the mathematical expression for conservation of linear momentum. At this point here, what next? Observe something, please. Come back here, please. From here, we will say that from here, observe that FA and FB are hitting each other in opposite direction. So for this to be in equilibrium, FA plus FB is equal to 0, right? So at this point here, I'll take FB to the other side here. I'll have that FA is equal to minus FB. This idea was from Newton's third law of motion. This idea was from Newton's third law of motion, that for every action there is an equal and opposite reaction. This is negative, opposite reaction. So for every action, right, there's an equal and opposite reaction. So if this is true, here, from here now, if this is true, record something, please. This is force. Record that within that force is equal to mass times acceleration. This from Newton's second law of motion. So record this one here, that force is equal to mass times acceleration. It is true. I'm having force in terms of A and force in terms of B. So I'll have force. So I'll be having force. My force now is what? MA. So I'm having what? MA and AA. That is force at fourth. Let me call it force at section A. So for force at section A, force can be expressed as mass and acceleration. So replace force with what? Mass times acceleration. So that I will have this force now is now MA, but I'm having section A, or AA here. So it's now equal to negative force is what? Force is MA. So I'll be having this is section B and AB. This is like the stuff here. At this point here, what's your next task? My next task now at this point is to simplify something here. Check very well here. From here now, record that we know something very well. Record that acceleration A is equal to change in velocity all over time. So my change in velocity can be expressed as what? V minus U all over T as change in velocity, which is correct. So we're saying that anywhere I see acceleration, I can put in what? V minus U over T. So put in anywhere acceleration, put in this value here. So I'm having that MA from here now. I have that MA, this MA here, acceleration is what? Everything here. So I'll have into V into VA minus UA all over TA. So acceleration, replace acceleration as what? V minus U over T. But I'm having A here, put AAA in terms of A. Is now equal to negative, I'm seeing MB here, so I'll have MB into, I'm seeing acceleration at section B. So acceleration here becomes V minus U over T, but in terms of B. So VB minus UB all over TB. I'm at this point here. So at this point here, what's my next task? Observe that these two bodies are hitting against each other at the same time. So this occur, this during collision, this stuff here occur at the same time. So I'm saying that TA is equal to TB. So TA is equal to TB. It means that these two here we cancel out. Mathematically correct. At this point here, what next? I'll be having MA, so into VA minus UA is equal to minus MB into VB minus UB as my equation left. Use MA, expand this one. Use minus MB, expand this one here. I have MA times VA is MA VA minus MA times UA becomes MA UA is equal to minus MB VB minus is plus MB UB. At this point here, I'm saying V and V, U and U. Take correct items here. So I'll have MAVA. This one here becomes plus, negative become plus MBVB is now equal to, I'm seeing this one here. That's or perhaps if I take this one here, I'll be having MAUA next up plus MBUB. All right, I have this one here. So this is my equation, but not that arranged. So let me just arrange this normally. So I'll take this one here first. I'll be having MAUA plus MBUA UB is equal to this one here, MAVA plus MBVB. This becomes the equation of conservation of linear momentum, that MAUA plus MBVB is equal to MAVA plus MVBV. As you can see, the equation of conservation of linear momentum. All right, where M is called the mass of body A, UA is called the initial velocity of body A, MB mass of body B, UB initial velocity of body B is equal to MA mass of body A times VA final velocity of body A, MB mass of body B, VB velocity of final velocity of body B, as you can see. All right, let's use this idea to solve some past question, and let's see what we can do. Example 1. A body of mass 2 kg move with an initial velocity of 5 meter per second and collide with another body of mass 15 kg move at 0.3 meter per second. If after collision the object of mass 2 kg moves with a velocity of 4 meter per second, what is the velocity of 15 kg body? Let's get this done. Solution. Our first task in science is to what? List out the given parameter. What are you given? So from there, I'm seeing that I have two mass. I have 2 kg and 15 kg. So let's call that one. Let's call 2 kg. Let's call the mass of body of object A and 15 kg of mass of body B. Let's use that way. So a body of mass 2 kg. So I'm having mass 2 kg. Let's call it MA 2 kg. MA is equal to 2 kg. All right, moves with an initial velocity of 5 meters per square seconds. So this mass here moves with an initial velocity U of A is what? 5 meters per second, and collide with another body of mass 15 kg. That's MB. Mass of body B to be equal to what? 15 kg at 0.3 meter per second. So U of B is simply 0.3 meter per second. If after collision the body of mass 2 kg, this one here, moves with a velocity of 4 meter per second, so that's VA 4 meter per second. And what is the velocity of 15 kg body? That's VB is unknown. I don't know VB. All right, let's solve this question here. After listing out this parameter, what your next value? Your next task per se. My next task is to record something. Record that we said the equation for conservation of momentum is given as MAUA plus MBUB is equal to MAVA plus MBVB as my equation for conservation of linear momentum. If this is true, let's put in value. What's MA? From here, MA is 2 times what's a UA? That's 5. I have this one here, plus what's MB? MB, of course, 0.3 times what's UB? UB there is 0. MB per se, MB is 15, please. 15 times UB, that's UB 0.3, is equal to what's MA? That's 2 times what's VA? VA, that's 4, plus MB is 15, yeah, times VB is unknown, so have VB here. At this point here, multiply through, that's 10 here, plus 45 at this point here. Sorry, 4.5 per se. 4.5 here is equal to 8 plus 15 VB. Simplify this one here. I'll have that 14. I'll have 10 plus 45 is 14.5 is equal to 8 plus 15 VB. So it's equal to, take 8 here, I'll have 14.5 minus 8 is equal to 15 VB. Sorry, VB. Alright, if I subtract 14.5 from what's it called there? Alright, here, subtract this 2 here, I'll have 6.5. 6.5 is equal to what there? Is equal to 15 VB. So my next task, you get VB here, divided by 15. Divided by 15. This cancel this here. VB is equal to 6.5 all over 15. Divide this 2 here. VB is equal to 0.43 meter per second as my final velocity for body B, as you can see. So we have tried to solve this question here. All right, let me explain something before we end this concept. For this concept here, I'm having mass A and mass B. So mass A is small. Look at mass A. This is 2 kilogram. Mass of A. Mass of B is bigger. That's 15 kilogram. That's 15 kilogram. That's for mass of B. So these two objects here are what? They are moving in opposite direction. This is before collision, right? So they are saying that after collision here, these two body. Look up this. Look up this. Look up. My question now is that if these two body collide together, would these two body move in this way, in this direction? So if these two body here, these two body collide, would they move in this direction or in this direction? So we're saying that the one that has bigger momentum. So let's say that if this one has bigger momentum, it means that the object what will go in this way. If this one has bigger momentum, the object what will go in this direction. So let's now get momentum of body A and body B to determine which direction which will each of them move. So let's say I have for A now. For A, momentum P is equal to mass times velocity. What's my mass of body A? That's 2 times velocity. That's U of body A. That's 5. Multiply these 2 here. I'll have 10 kilogram meter per second. Per second as my momentum for body A. Let's get momentum for body B. For B, I have momentum that P is equal to mass times velocity. That's U. Momentum P is my mass. That's 15 times velocity. That's U. What's my U of body B? That's 0.3. Multiply this to P is equal to 4.5 kilogram meter per second. Observe that. Look up, please. Observe that for body A, the momentum is bigger, and body B, momentum is smaller. So it means that the direction, if these two body hit, it's going to move in this direction. In this direction, please. This is the correct one. Why? This is body A and body B. So body A will hit body B, and hence they move in this direction. Why? Because A has a bigger momentum but smaller mass. This one has a smaller momentum but a bigger mass. So I'm saying that we don't use the mass to determine which direction the body will move. Observe that the one that has a bigger momentum, that's where the direction follows. So these are the concept behind collusion or perhaps conservation of linear momentum.